Hello everyone, this is fifth grade math and we will be learning how to, sorry about that, give me just a second. We will be learning fractions and we will be learning how to understand them. First, do you have any questions, comments, or concerns? Before we start today's class, I would like to offer you a chance to ask any questions from the last class. Please let me know and ask me now if you had any confusions from the last class or if you have anything to say or ask. So, did you need any help regarding the last class's information? Did it make sense? Do you have any suggestions or questions? Did you understand it? Are there none? Okay, let's go to the next part of our lesson. Okay, so today we're going to be talking about fractions. You have likely seen fractions before, but today we're going to focus on what they mean, not just how to use them. Fractions are used when we talk about sharing, dividing, or measuring something. By the end of class, fractions should feel more logical, less confusing, and overall clear. You should understand how a fraction works by the end of today's class. Before we start learning, make sure you have a paper and pencil nearby because throughout this class, you should be using the paper to write down your problems or answers to any problems and any important facts. You don't have to write down all the text on each slide, but you should be making sure you write down things that you think are important to remember to understand the topic. If you find something interesting or important and you want to remember it, then you should make sure to write it down. If I'm ever going too fast or too slow, you can interrupt me. You can raise your hand and tell me that, oh, you're going too fast or you're going too slow. And if you have any questions, please feel free to ask. Don't worry about interrupting. Just ask your questions whenever you get them so that I can explain it to you better. Here are our learning objectives. By the end of this lesson, you will be able to explain what a fraction is. You'll understand what a fraction is, and you'll be able to explain it to other people as well. That's how I know it. And you'll be able to identify the numerator and denominator. You'll also recognize equivalent fractions, and you'll be able to tell like and unlike denominators apart. You should be able to tell me what a fraction is in your own words by the end of today's class. You should know the specific terms for top and bottom, recognize when fractions equal each other, and know what unlike and like fractions are. All the information in this lesson is something you should learn to understand how fractions work. Memorizing comes second. First, you need to understand how it works so that you will understand the logic behind it, and then memorizing will come automatically after that. If you understand fractions properly, then memorizing won't be necessary because you already know and understand the logic in fractions. So this class isn't much about memorizing, it's more about understanding the logic behind. First, let's do a warm up. Before I teach you what a fraction really is, I want you to see how much you know so that you can compare your prior knowledge to the knowledge you have gained by the end of the class. On your paper, write down what you think a fraction is and write one real life example of a fraction. Don't worry about being wrong, this is just time to think. Take 3 minutes to consider the questions and write down your answers. The questions are, what is a fraction? and write one real life example of a fraction. If you finish early before the 3 minutes, write more real life examples of the fractions you can think of and explain your thinking to your classmates around you. You're allowed to discuss, you don't have to be quiet. You can discuss with your classmates on what the answers are. And if you don't know what a fraction is, you can make guesses and work with the classmates around you. Take 3 minutes right now. We'll discuss together after the 3 minutes are up. We are halfway through the time. Make sure that you have your answer written down and you are discussing with your classmates on what you think the answer is. Okay, your time is up. Let's go to the next part. A fraction represents a part of a whole. Okay, we're learning right now what a fraction is. A fraction represents part of a whole. The whole must be divided into equal parts. It is very important that the parts are equal. If the parts are not equal, then the fraction doesn't make sense, and you cannot really assign it a numerator and a denominator. So if the parts are not equal, then it really isn't a fraction anymore. Overall, a fraction represents a part of a whole. The whole is divided into equal parts. So for example, let's say I have a pizza and it's cut into 8 equal slices. If I eat 3 of them, I ate 3 out of 8 slices. The fraction would be 3 over 8. Note, throughout these slides, the fractions may be formatted differently, but please know that 1/2 is the same as, sorry, Please know that 1/2 is the same as this here. Here you see how the 1 is on the top and the 2 is on the bottom? Here they're side to side, right? But this actually means the 1 is on the top and the 2 is on the bottom. So please be aware that these two formats are the same. Now we'll be learning about the parts of a fraction. Each fraction has two parts. The top number is the numerator and the bottom number is the denominator. The denominator tells us how many equal parts the whole is divided into. The numerator tells us how many of these parts we are talking about. For instance, if I ate 3 slices out of a whole pizza divided into 8 parts, then the fraction would be 3/8 because 8 is the number that the whole is divided into and is therefore the denominator of the bottom. 3 is the number of slices that was eaten out of the whole and therefore it is the numerator or the number on the top. Overall, numerator the numerator is the top number and it is a part of a whole. The denominator is a bottom number and is the whole. For instance, if we go back to here, a fraction is a part of a whole and the whole is divided into equal parts. We learned that, right? So the bottom number is how many equal parts there are, and the fraction is what part of that whole. Like, let me give you another example. Let's say I have a brownie, a big brownie, okay? The brownie would be the whole. And then if I cut the brownie into different parts, let's say I cut it into 5 parts, and then I ate one part of it, that would be one eaten out of 5 parts of the whole. Then what would my fraction be? It would be 1/5, with the 1 on the top and the 5 on the bottom. That is because 1 is the part of the whole, and 5 is how many pieces the whole is split into. For another example, let's say I have an apple, and I cut that apple into 6 pieces. If I eat 3 of the pieces, then that's 3/6. And that means that the fraction would be 3/6 because 6 is the amount that the whole is divided into. If the apple is the whole and it's divided into 6 parts, that's 6 parts made out of that whole. And then let's say I ate the 3 slices, right? That's 3 gone. That means 3/6 were eaten. So the fraction would be 3/6. Now let's look at some examples of parts of a fraction. The fraction 5/6 has a numerator of 5 and a denominator of 6. This represents 5 parts out of the 6 parts of the whole. The fraction 3/5 has a numerator of 3 and a denominator of 5. This represents 3 parts out of the 5 parts of the whole. Now let's see the fraction 2/3. The numerator, meaning the top number, is 2. And the denominator, which is the bottom number, is 3. You see there's 2 on the top and a 3 on the bottom. This represents 2 parts out of the 3 parts of the whole. The fraction 1/6, you see 1/6. The numerator is 1 because 1 is on the top here, and the denominator is 6 because 6 is on the bottom here. This represents 1 part out of the 6 parts of the whole. If the whole is split into 6 parts, we have 1 part of it, then that is 1/6. The fraction 3/4 has a numerator of 3. See, there's a 3 on the top, and a denominator of 4. There's a 4 on the bottom. This represents 3 parts out of the 4 parts of the whole. Now the fraction 3/8. It has a numerator of 3 because see, there's a 3 on the top, and a denominator of 8 because there is an 8 on the bottom. This represents 3 parts out of the 8 parts of the whole. The whole is the whole is equal to 1, right? But that one whole is split into 8 parts, and 3 parts are taken out of the 8 parts. That means 3 over 8. The numerator is 3 and the denominator is 8. So those are the parts of a fractions. So I'll just always remember that the top is the numerator and the bottom is the denominator. The top is how many out of the denominator, okay? Remember that. The top is how many are taken out of the bottom. Here is a pie chart model. This is a pie chart. It's a circle divided into different parts. You see, notice how one part is shaded. This is a circle split into 4 parts. Notice how one part is shaded in with this color of blue. This whole circle is one whole. One whole, okay? It's divided into equal slices. How many slices is it divided into? It's divided into 4. See? There's 4 parts of it. 1 here, 2, 3, 4. So let's think of it as a pizza. If this is a pizza, it's divided into 4 slices. If one slice of it is shaded out, you see one out of the 4 is shaded. The fraction is 1 over 4. Fractions help us describe how much of the whole is shaded or used. Because it's, you see, 1 out of the 4, there's 3 left, right? But that's some mistakes that could be made is like 1 over 3 because there's 3 left. But this 1 is actually part of the whole, and therefore it's actually 1 over 4, not 1 over 3. So basically, you put the shaded part over the total number of parts, okay? So since the total numbers of parts is 4, then the fraction is 1 over 4. Fraction bars. These bars represent one whole. This is, you see how we used the circle to represent one whole? Where there's another way of representing it, and that's with fraction bars. If you imagined this as a pizza, you can imagine fraction bars as chocolate bars. If this is one whole chocolate bar, it can be split into halves, into 2 pieces. But let's say you have 3. You want to have 3 pieces. Then you can split it into 3 parts. Then you can do 4 if you wanted, or 5, or 6, or 7, or 8. But you will still always have the same amount. If you have a chocolate bar and you split it into a bunch of different pieces, that doesn't mean you have more chocolate. It just means you have the same amount of chocolate just split into different pieces. You see, these bars each represent one whole. One bar is divided into 2 equal parts. Another is divided into 3 equal parts. The next is divided into 4 equal parts, and then 5 equal parts, 6 equal parts, 7 equal parts, and 8 equal parts. However, all of these bars, notice no matter how many pieces it's split into, it's always the same as one whole. They're all the same length, you see? It didn't get longer or shorter based on how many parts it's split into. When the whole is divided into more pieces, each piece gets smaller. That's why one half is bigger than 1/4. You see, we have 1/2 here and 1/4 here. 1/2 is bigger because there's only 2 pieces that are split, so it would be a bigger part of the whole. But however, this 1/4 needs to be equal with all the other 4 pieces, so it will be smaller. But either way, the whole, remember this, it's always the same. No matter how many parts you split into, the full amount will always stay the same. Now let's learn about equivalent fractions. Equivalent fractions are when two fractions have different. Okay, wait, hold on. Equivalent fractions. It's based on different values and same value. Okay. So equivalent fractions, they all have the same value. Uh, unequivalent fractions, inequivalent fractions don't have the same value and have different values. Some examples of equivalent fractions are these examples. 1/2 is equal to 2/4, and 2/4 is equal to 4/8. 1/2 is also equal to 4/8. Equivalent fractions, they look different, but they represent the same amounts. 1/2 looks very different from 4/8, right? They don't even have the same numbers. But even though the numbers change, the value stays the same because the whole has not changed. How do I know 2/4 is equal to 1/2? It's because the fraction represents 2 out of 4. Half of 4 is 2, and therefore 2/4 is equal to 1/2. If we go back to the previous slide, I can prove to you that 1/2 is the same as 2/4 because you see we have 1/2 here, but if we take 2/4 here, you see how the lines match up? It means they're the same length. 1/2 is equal to 2/4. And then if we look at the 4/8, that's also the same. You see this line aligns with everything else. So it's equal to 1/2, and it's also equal to 2/4. Now we'll learn about equivalent fractions. In the image to the side, the fractions 1/2, 2/4, 3/6, and 4/8 are represented in by the shaded areas. You see how half of the whole is shaded in green, and then 2/4 of the whole is shaded in green, and so is 3/6 and 1/8. 4/1/8 are shaded in, 3/6 are shaded in, and 2/4 are shaded in, as well as 1/2. But they all look the same length, right? If we're measuring from here to here, it would be the same length as here to here, and here to here, and here to here. They're all the same length, even though they look different. As you can see, they all make up half of the whole, and therefore all those fractions are equal. The shaded area stays the same size. Think about cutting an apple. If you cut it into more pieces, it only gives you more parts to eat, but it doesn't give you more food. Okay, let's say you have a cake. If you cut more pieces of the cake, you'll have more pieces, you'll have more parts, but you'll still have the same amount of cake. Or let's say there's a jar with water. Think of it this way, water might be easier to think about. Let's say you have a jar of water and you're pouring it into cups. Even though, let's say you put less in each cup and you fill 8 cups. So each cup will have 1/8. But that doesn't mean the total amount of water has changed. It just means you split it into more parts. So the amount does not increase or decrease, but the pieces do. You can increase and decrease the pieces, but not the amount. It'll always stay one whole based on which you're using. Now it's your turn. On a paper, write some fractions that are equivalent to 1/3. Take 3 minutes. Here is a hint. When you multiply the top and bottom numbers of 1/3 by any number, the fraction it gives you is equivalent to 1/3. Here we have an example. If you're multiplying the numerator and denominator by the same number, it gives you an equivalent fraction. You see here we have 2/3. Now if you multiply the numerator by 2, then you also need to multiply the denominator by 2, and that equals 4/6. You need to multiply both the top and bottom by the same number. Let's say I have 2/3 again. Then if I want a bigger number that's equivalent, then I need to multiply the top by 3 and the bottom by 3. Or the top by 4 and the bottom by 4. Or the top by 5 and the bottom by 5. And see, you can change this number to anything you want. You can increase the number if you want the equivalent fraction to be bigger, but you can also decrease it if you want it to be smaller numbers. So it's really up to you. You don't have to use 2. Make sure you find at least hold on. Make sure you find at least like five fractions that are equivalent to 1/3, and your 3 minutes starts now. If you have any questions, you can also ask them now. You are halfway through your 3 minutes. Make sure that if you finish, you can discuss and share your answers with the people around you. But make sure you have your answers written down so that you have them to refer to later, okay? Okay, your 3 minutes are up. Let's see this together. So here are some answer possibilities: 2/6, 3/9, 4/12, 5/15, 6/18, 7/21, 8/24, 9/27, and 10/30. There can be multiple other answers as well, but these are just a few examples. Let's see how we got each one. We got 2 6 if we multiplied the top and bottom by 1/3 by 2. If we multiply 1 times 2 equals 2, and 3 times 2 equals 6. So that makes 2 over 6. We get this second equivalent fraction by multiplying the top and bottom by 3. 1 times 3 equals 3, and 3 times 3 equals 9. So 3 ninths is equal to 1/3. Now for 4/12. We multiply the top and bottom by 1/3 by 4. 1 times 4 is 4, and 3 times 4 is 12. Now 5/15. We multiply the top and bottom by 5. 1 times 5 equals 5, and 3 times 5 equals 15. That makes 5 over 15, which is equal to 1/3. Now we have 6 over 18. If we multiply the top by 6 and the bottom by 6, 1 times 6, we're talking about the 1/3 here, by the way. 1 times 6 equals 6, and 3 times 6 equals 18. That makes 6 over 18, which is equivalent to 1/3. Now for 7 over 21. If we multiply 1 by 7 equals 7, and 3 times 7 equals 21. That means 7 over 21 is equal to 1/3. And we did the same thing for all of these, except for 8 over 24, we multiplied the top and bottom by 8. For 9 over 27, we multiplied top and bottom by 9. And for 10 over 30, we multiplied the top and bottom by 10. You see? This you can see clearly. If we get rid of the zeros, then it's the same as 1/3. So basically, 1 times 10 equals 10, and 3 times 10 equals 30. That made 10 over 30, which is equal to 1/3. There are multiple other examples. It can go on forever, it can be infinite. But these are just a few examples that you might have gotten. You could have gotten something different, but make sure that your answer is right by checking. Make sure you multiplied both the top and bottom, and the number that you multiplied the top and bottom by have to be the same number, okay? That's how you check if your answer is right, if your answer that you got is not up here. Okay, let's go to our next part. Find 3 equivalent fractions for each of the fractions given below. Take 5 minutes to do so. So basically, you're going to do the same thing that you did with the 1/3 here, except you're going to do it to all of these. You can find 3 equivalent fractions for each one. And remember, this is how you find equivalent fractions. You multiply the top and bottom by the same number. So for 1/2, for the first equivalent fraction, multiply the top and bottom by 2. For the second equivalent fraction, multiply top and bottom by 3. And for the third, multiply top and bottom by 4. Okay? And you have to do that for all of these. So take like 5 to 10 minutes to do it, and your time starts now. And if you finish early, feel free to check your answers and talk to the people around you to make sure that you're all getting relatively the same thing. During this 5 to 10 minutes, make sure you also ask any questions that you might have. you are halfway through your time, make sure you have your answers written down. And if you have already finished, make sure you discuss with the people around you. Okay, 5 minutes is up. If you guys need more time, you can unmute and tell me now. If you don't need more time, you can just stay quiet and I'll move on, okay? Do you guys need more time? Okay, let's move on then. Like denominators. Like denominators means the bottom numbers between two or more fractions are the same. That means the pieces are cut into the same sizes. Unlike fractions are when the denominators are different. So let's say we have unlike fractions, then the denominators will be different from each other. Okay, 1 second. Um, there we go. Here are some examples of like fractions. 3/8 and 5/8 are like fractions because they have the same bottom, and the bottom number is 8. For both fractions, because the bottom number is 8, that means that they have like denominators and they're like fractions. Now some other examples are 4/5 and 3/5. They both have a denominator of 5 and therefore they are like fractions. 2/3 and 1/3 both have a denominator of 3, so they are like fractions. 1/4 and 3/4 have the same denominators, so that means that they're like fractions as well. So basically, if they have the same denominator, they're called like fractions. Now, if they have unlike denominators, that means the bottom numbers are different. When fractions have unlike denominators, the whole is divided into a different number of equal parts than the other fraction or fractions that is being compared to. Because the number of parts is different, the pieces are different sizes. This makes unlike denominators hard to compare. Some examples are 1/2 and 1/3. They 1/2 has a denominator of 2 and 1/3 has a denominator of 3. That means that they're unlike fractions because they have different denominators. If the denominators are unlike, that means the fractions are unlike. Another example is 3/4 and 2/5. 3/4 has a denominator of 4, and 2/5 has a denominator of 5. Therefore, they are unlike fractions. 5/6 and 1/8. 5/6 has a denominator of 6, and 1/8 has a denominator of 8. That means they're unlike fractions. 3/8 and 3/7. 8 3/8 has a denominator of 8, and 3/7 has a denominator of 7. And because the denominators are unlike, that means the fractions are also unlike. Don't get tricked by the top. You see how the numerators here are the same? 3 and 3? That does not mean that they're like fractions. It has to be the denominators that are same. It has to be the bottom number that is the same, okay? Now we have a 10-minute practice. Here are a bunch of examples of fraction pairs. And you don't have to write everything on your paper. Just write the number, and next to the number, write whether the fractions are like or unlike, okay? For example, if I have 4 9s and 7 9s, I would decide whether the fractions are like or unlike. And on my paper, I would write 1, and then I would write my answer, which is unlike, or like if the answer is like. In this first example, the answer is like. So if I write it on paper, I would write 1, number 1, and next to it I would write like. Do the same for the rest of these and take 5 to 10 minutes. Your time starts now. Okay, it's been 5 minutes. I think 10 minutes is a little too long for this. So, was 5 minutes okay? Are you all finished? I'm going to move on now. If you need more time, you can unmute and tell me now. Do you need more time? Okay, let's move on. Okay, these are the most important ideas from today. If you understand these, then you're doing really well, okay? Um, First of all, fractions are parts of a whole. That's the most important. Denominators are the total equal parts of the whole, like how many parts the whole is cut into. Numerator is the amount of parts we have, the amount of parts that are being represented. So denominator is bottom, numerator is top. Equivalent fractions have the same value, and like denominators have the same bottom number. Okay, here is the exit question, and then after this we will be done. Take 2 minutes to give me two examples of equivalent fractions. So, get one pair of equivalent fractions and get another one. And then write whether this is like or unlike. Three, is 2/3 and 2/5 like or unlike? Write your answers on your paper to check your understanding. And in the next class, we will use these ideas to compare fractions and learn how to add, subtract, multiply, and divide them. You get 2 minutes starting now. Answer these two questions and write it on your paper. Okay, your 2 minutes are up. The first one, for the first question, all of your guys' answers will be different. But for the second one, you should have gotten that 2/3 and 2/5 are unlike because even though the numerators are the same, the denominators are different and therefore they are unlike fractions. We're finished. I hope you have a great rest of your day. Your homework is to make up 5 fractions and find 3 equivalent fractions to each fraction that you make. So get 5 fractions, you can make them up by yourself, and find 3 fractions that are equivalent to each one of the 5 fractions. Does anyone have any questions? Was I going too fast or too slow? Do you have any confusions? Please unmute and tell me now if you have anything that you want clarified. Okay, then we're finished for today. Um, make sure you do your homework. You can get some extra practice if you want, and come back to this video if you want to relearn anything or get clarification on anything. And if you have any questions that come up, you can ask me in the next class.